Hi class, this is lesson 11.5, areas of circles and sectors. So theorem 11.9 is the area of a circle. The area of a circle is pi times the square of the radius. And this is something you've already worked with. Area for a circle is pi times r squared, pi r squared. So let's use the formula for the area of a circle. Example 1 says find the indicated measure. Here we want to find the area. So area we know is pi times our radius squared. That gives us our r right here. So area equals pi times 4.2 squared. And if you put that in your calculator, you'll find that it's 55 and 42 hundredths. And my units will be meters squared. B says find the diameter. Well, we know we've got this formula, area equals pi r squared. We can find the radius, and then we can just multiply it by 2 to find the diameter. So for A, we're going to put in 201 equals pi times our radius squared. Now we need to solve for r. So we can divide both sides by pi. And that would give us r squared equals 201 over pi. And then we can take the square root of that. So r equals, now if you put that all in your calculator, and then that's going to give us our radius, but we need our radius times 2. So we're going to take this 201 divided by pi and multiply it by 2 to give us our diameter. So if you put this all in your calculator, you'll find that your diameter equals 16. And then my units there would be inches. Notice how, though, I don't want you to do any of this, put any of this into your calculator until the very, very end, until the very, very last step. All right. On your own, you should pause it and try these two. Okay, so this one wants us to find the area, and it's giving us the diameter, and we know that because see how it gives us this line all the way across? So my radius here is going to be half the diameter, so 4.5 centimeters. So area equals pi times our radius squared. So our area is going to equal pi times 4.5 squared. So area equals, if you put in your calculator, pi times 4.5 squared, you should get 63 and 62 hundredths, and that unit would be centimeters squared. Part B here says find the radius, so we know area equals pi times the radius squared. And I should be putting a box around all my answers. These are all the answers for each one so far. But area equals pi r squared. We know our area is 154 feet squared. In this equation, my only unknown is my radius, so I can divide both sides by pi here. That'll cancel. That'll leave me with r squared, so I'm going to have to take the square root of both sides. So r equals, if you put into your calculator, 154 divided by pi, and then take the square root, you'll get about 7.00, and my unit would be feet. Sectors. It says a sector of a circle is the region bounded by two radii of the circle and their intercepted arc. So here's a radius, they're radii, that's plural. And this part inside here, that's a sector. So the ratio of the area of a sector of a circle to the area of the whole circle, pi r squared, is equal to the ratio of the measure of the intercepted arc to 360. So this is similar to what we did in the last lesson, where we said the arc length out of 360 is similar to the arc length out of the whole circumference is similar to the arc measure out of 360. So we can say the arc of sector APB, and it shouldn't say arc here. That should say area of sector APB over pi r squared. That's your entire area. Equals the measure of arc AB out of 360. Now, we're going to cross this out. I don't want you to memorize this extra little formula. As long as you can set up a proportion, you'll be fine with these problems. So let's turn the page. Example 2, it says find areas of sectors. Find the areas of the sectors formed by angle RQS. So step 1 here, it says find the measure of the minor and major arcs. So this arc is going to be 63 degrees because that's what this angle is. And then this larger arc is going to be 360 minus the 63 degrees, which is 297 degrees. So that's my larger arc. Step 2, find the areas, notice it says plural, of the small and large sector. So let's do the small sector first. So for my small sector, I have 63 degrees out of 360 degrees equals, now it's the area of the sector, we don't know what it is, so it's x, out of the area of the entire circle is pi times 5 squared, so times 25. Now to solve this, we've been doing quite a bit of these lately. We're going to just solve by cross multiplying. So you'll have x times 360 equals 63 times 25 pi. And then we'll divide both sides by 360 to get x alone. So then that will leave us with x equals 13 and 74 hundredths. And now we don't have a unit on here anywhere, so we're just going to use U for units. So that's how we find the area of the small sector. Now we want to find the area of the large sector. So I'm going to put the large sector right here. So for our large sector, that's 297 degrees out of the total 360 degrees. So that's x. We don't know what the area of the sector is, out of pi r squared. So my radius is 25, or my radius squared is 25 times pi. And just like we did in the last problem, we're going to cross multiply here. So I'll have 360 times x equals 297 times 25 pi. And then we'll divide both sides by 360 to get x alone. Just a minute here. So doing that cancels that out, so we find that x equals 64.80, and again we don't have a unit, so we'll just say units. This should be units squared for both of these because we're talking about an area amount. So the small sector is this, and the large sector is this. So you should pause it and try on your own the second problem here. Okay, for this second problem here, this arc is 106 degrees, and the larger arc, if you do 360 minus 106, that's 254 degrees. So for the small sector, you're going to set up the problem 106 degrees out of 360 degrees equals x out of, now pi times your radius squared. My area for this one right here, area equals pi times 9 squared, so that's 81 pi. So out of 81 pi. And we've been doing a lot of cross multiplying, so hopefully you can cross multiply these at this point. Cross multiply here and here. So we'll say 360x equals 106 times 81 pi. Divide them both by 360. That should leave you with x equals 74 and 93 hundredths, and my unit there would be feet. So let's now find the large sector. So for the large sector, the arc length is 254 degrees out of the total of 360 degrees. So the area of the sector is x out of, my area of the entire circle is again still 81 pi. Now if we cross multiply that, just like we did on the last problem, here and here, we'll have to say 360x equals 254 times 81 pi. Divide both sides by 360. So that will leave us with our answer here, And we should find that x equals 179 and 54 hundredths, and my unit would be feet squared. And just like on the last one, that should be feet squared as well. Okay, this next example says use the area of a sector theorem. So now we're going to use the area of a sector theorem to do something a little different. It says use the diagram to find the area of circle C. So here we know the area of this sector, and we know what this arc length is. So we know this arc length is 45 degrees out of 360 degrees. We know the area of our sector is 22 meters squared, but it says find the area of circle C. So there's our unknown right there, that area. So we've got this all set up. We know this is going to be a meter squared, our answer is. So let's cross multiply to solve this. I'll cross multiply here and here. So I have 45x equals 22 times 360. Divide both sides by 45. And that will leave us with x equals 176, and my unit is meters squared. So you should pause the video and try the next one on your own. Okay, this problem, find the area of circle G. So again, we have the area of the sector. We know the measure of the sector, so therefore we know the measure of the arc length. So we can say 80 degrees out of 360 degrees equals 6.4 yards squared out of, and we don't know what the entire area for the circle is, that's what we're looking for, so x yards squared. So now that we've got our problem set up, we can just do a little bit of cross multiplying here. So we have 80 times x equals 360 times 6.4, it should be a 6.4. Divide both sides by 80. That cancels, and that should leave you with x equals 28.8, and my units would be yards squared. All right, let's look at the last page. So we got a couple of real world problems here where we need to find the area. It says a contractor needs to cut a section out of a rectangular piece of wood as shown. To the nearest square inch, what is the area of the wood? So we can find the area of our whole entire shape. So I know this side right here altogether is 7 for our big rectangle then. For a rectangle, we know area equals base times height. So the area of my rectangle is 11 times 7, so my area is 77 inches squared. But I'm going to need to subtract from that this square right here, and that's 3 inches by 3 inches. So for the area of a square, area equals side squared. So for the square, let's say subtract square. Said area equals s squared, so area equals 3 squared. So my area for the square is 9 inches squared. And then I'm going to also need to subtract this semicircle right here. So we're going to subtract semicircle. Now, and I know this is a diameter, so this is 180 degrees. So I can say 180 degrees out of 360 degrees equals, well, I know my diameter all the way across is 3, so halfway across for that circle would be 1.5. So my area that I'm looking for is x over pi times 1.5 squared. Now if you do a little cross multiplying here, cross multiply here and here, you'll find that your area for that semicircle is 3 and 53 hundredths, and that would be inches squared. So let's do the final work here. We got 77 total inches squared, and we're going to subtract 9, and then we're going to also subtract 3 and 53 hundredths. So that leaves us with a total of 64.47, and the directions here says to the nearest square inch. So that would be 64 inches squared. This next one says, again, find the area of the figure. So we've got a triangle there and a half circle. So for the triangle, we know area equals 1/2 the base times the height. So the area equals 1/2 7 times 4. So the area of that triangle equals 14. And the units would be feet squared. Then we also have a semicircle, and we're going to add it because we want both of them. And for our semicircle, we know it's 180 degrees out of 360. And again, I know that because this is a diameter, so I know this length is 180 degrees. Equals the area of the circle, or the semicircle we don't know, so x out of, and the area of the entire would be pi times the radius. So r here, that's going to be 7 divided by 2, so it's 3.5. So pi times 3.5 squared. So I set up that circle. If you do your cross multiplying, you'll find that x equals 19 and 24/100ths, and that would be feet squared again. So our final answer here, it just says find the area of the figure. It doesn't say what to round to. So I'm going to do 14 minus 19 and 24/100ths. Oops, not minus, plus. We're adding both of them together here because we want both the shapes. So it's 33 and 24/100ths, and my units would be feet squared. And that's my answer. That's the end of the lesson. Make sure if you have any questions, you ask me about it, and have a great day.